ID, The Future, a podcast about evolution and intelligent design.
Welcome to ID The Future. I'm your host, Andrew McDiarmid. Well, today I'm speaking with Jean-Pierre Luminet about his new book, The Big Bang Revolutionaries, the untold story of three scientists who re-enchanted cosmology, published by Discovery Institute Press. The discovery that the universe had a beginning is one of the most remarkable achievements of 20th century science. It sparked a cosmological paradigm shift and offered a radical new way to understand our world. But alas, the three scientists most responsible for the Big Bang Revolution are largely unknown to the general public and underestimated by astrophysicists and cosmologists today. The Big Bang Revolutionaries amends the record by telling the remarkable story of how three men, Belgian theoretical physicist George Lemaitre, Russian physicist Alexander Friedmann, and the Russian-American physicist and cosmologist George Gamow, in the face of conventional scientific wisdom, offered a compelling new view of a singular creation of the universe in what Lemaitre termed a primeval atom. Dr. Luminet is a French astrophysicist specializing in black holes and cosmology. He is Emeritus Research Director at the French National Centre for Scientific Research. He is a member of the Astrophysics Laboratory of Marseille and the Universe and Theories Laboratory in Paris. Luminet has been awarded several prizes, including the George Lemaitre Prize for his work in cosmology, the UNESCO Kalinga Prize, and the Einstein Medal for the popularization of science. He has published more than 20 science books, 8 historical novels, and 8 poetry collections. The asteroid 5523 Luminet was named in his honor. Jean-Pierre, it's indeed an honor to welcome you to ID The Future.
Thank you, Andrew, for your kind invitation. I'm really glad to have the opportunity to share with our listeners the great history of modern cosmology, and thank you for your very nice introduction.
Yes, absolutely. You're welcome. Well, you are a theoretical physicist who is world-renowned for your work on black holes and cosmology, but you've also published several works on the history of science. Now tell us, why do you think the history of science is important to know?
Yes, the French philosopher of the 19th century, Auguste Comte, wrote, "You can't fully understand the science until you know its history." And I think it's deeply true. However, in my career of astrophysicist, I discovered relatively lately the detailed history of my discipline by reading the wonderful essay of Arthur Koestler, The Sleepwalkers. And I was especially fascinated by the works and life of Johannes Kepler. Then I began to read intensively dozens of learned biographies of the greatest scientists in the history of astronomy, from antiquity to modern times. And after that, I want to popularize the history through a series of 8 novels, as you mentioned, that I published in French first between 1999, if I remember, and 2022 for the last one. And so I have, in these novels, I have successively recounted in the form of novels, the extraordinary life and works of ancient scientists such as Euclid, Aristarchus, Hipparchus, or Ptolemy, followed by an episode in Arab Muslim astronomy, then Copernicus, Tycho Brahe, Kepler, Galileo, Newton, and finally the scientists of the 18th and 19th century. These novels have been translated in a dozen of major languages, including Chinese, but unfortunately not in English, although nothing equivalent exists, as far as I know, in Anglo-American literature. Well, of course, these novels, although historically well documented, left a certain amount of room for the imagination. But at the same time, I embarked on a much more professional study of the history of relativistic cosmology, my specialized discipline, when I realized, in fact, that it was very poorly known, including by professional cosmologists themselves. and above all, that it was often summarized in a very inaccurate way. So I turned to the primary sources, generally ignored, except by historians, of course, very specialist historians, and reading all the original articles by Einstein, by Friedman, Lemaitre, Hubble, De Sitter, Eddington, and many others. So this book, The Big Bang Revolutionaries, is really the result of 30 years of historical research on the subject.
Wow. So you were hooked. You read some books on the history of science and you loved it. And it sounds like you've done a lot of research and it's coming to bear on this book that you're putting out. That's wonderful. Well, why was the Big Bang Theory a scientific revolution?
Oh, yes, it was surely a scientific revolution. Well, you know, in the field of cosmology, it's generally admitted that a picture of the universe, large-scale picture of the universe, has undergone just three fundamental scientific revolutions: the Copernican Galilean one, the Newtonian revolution, and the general relativistic revolution, which is the subject of the present book. Well, in the first one, the Copernican Galilean revolution, as you know, the Earth was no longer considered as the immobile center of the universe. In the Newtonian revolution, the universe was considered as infinite in space and time, and all the motion of celestial bodies were governed by the universal law of gravitational attraction. In the general relativistic revolution, the subject of this book, space-time is curved by gravity. And a natural consequence of that, namely Einstein's equation, is that space cannot be static. Namely, its size must vary with time. In fact, I could add, in the idea of scientific revolution in cosmology, that today it's possible that we are living through what will be recognized someday as a fourth cosmological revolution, with the emergence of new theoretical models based on quantum gravity. Well, it's not the subject of this book, but I have written recently a book about that. Okay. Well, however, in the absence of experimental verification and formal completeness, none of these new approaches like superstring theory, loop quantum gravity, and so on, is guaranteed to be successful. So only time will tell if a fourth cosmological revolution is in the making. But it's clear that the Big Bang ideas about the universe was really a scientific revolution.
Okay. Yeah, that's a good breakdown of the previous revolutions that have come up to the one we're in now. And you're even hinting at a quantum revolution that may occur at some point, which will again enlarge our understanding of this universe. Well, the discovery of the Big Bang is often attributed to the American astronomer Edwin Hubble or the German-born theoretical physicist Albert Einstein. Now, you show this to be historical error. Although these gentlemen are important in their fashion with regard to this revolution. Tell us why it's incorrect to credit Hubble and Einstein. Why are they not the fathers of the Big Bang?
Yeah, yes. Well, in fact, many widely read scientific writers attribute the concepts of the expanding universe and the Big Bang theory to two very famous men of science, namely Edwin Hubble and Albert Einstein. However, although Hubble did indeed experimentally demonstrate the linear relation between the spectral redshift of galaxies and their distance from us, he neither discovered such systematic spectral shifts, because the discovery goes back to the American Vesto Slipher, nor did he accept the relativistic interpretation of this observation, namely the expansion of space itself instead of the proper motion of galaxy as he believed. In fact, as for Einstein, which is the genial inventor of the theory of relativity, we will see that how he rejected for more than 10 years the idea of an expanding universe, apparently on the basis of philosophical prejudice. And he stopped, what is funny, he stopped working at the beginning of the 1930s. He stopped working in the field of cosmology as soon as, faced with observational evidence, he had to change his opinion.
Okay. But arguably, you could say that Einstein kicked things off. I'm noting here from your writing that in 1915, Einstein provided the correct field equations for a relativistic theory of gravitation. And this really was a way to reframe our understanding of the universe, that gravity was not a force, but an effect of the curvature of space-time. So he isn't a father of the Big Bang, but he kicked things off. He started the party, perhaps.
Yeah, sure. Really, Einstein is, of course, the father of general relativity theory, which changed completely our view of the world. The same as you mentioned before, rightly, but I didn't mention the revolution of quantum mechanics at the same time. And we should see that quantum mechanics will be included a little bit later in the frame of relativistic cosmology. But in fact, in my book, I tried to make clear the respective contributions of the scientists who participated in the elaboration of the Big Bang Revolution. So to summarize, Einstein created the theory of general relativity. So he wrote the field equations governing the physical and geometrical properties of the universe. Alexander Friedman, a few years later, discovered the non-static solutions for this equation, Einstein's equation, describing the time variation of space, and he suggested the possible beginning of the universe in an initial singularity. Few years later, in the 20s, George Lemaitre was the first to link the theoretical concept of the expansion of space, coming from general relativity, to the observed apparent motion of galaxies made by American astronomers like Hubble and others. So Lemaitre laid the foundation, really the physical foundation of the Big Bang models. Whereas, in fact, Friedman laid the mathematical foundation. Lemaitre laid the physical foundation of the future Big Bang models. He anticipated the fundamental role played by quantum mechanics and even by vacuum energy. Also, he predicted a phase of accelerated expansion of the universe due to a kind of repulsive field of energy. So decades in advance compared to the modern cosmology, as we have the occasion maybe to talk about the state of modern cosmology with accelerating expansion of the universe. For Hubble, well, of course, he proved the fundamental thing. He proved the extragalactic nature of spiral nebula in 1925. Also, he experimentally established the law of proportionality between the apparent recession speed of galaxy and their distance, according to what was called initially the Hubble law, and now it's called the Hubble-Lemaitre law, since it was, in fact, first recognized by George Lemaitre. Next, Gamow, finally, showed how light elements, such as hydrogen, deuterium, helium, were formed in the early, very hot universe, very early phase of the universe. And with his collaborators, like Halfer and Hermann, he predicted the existence of the cosmic microwave background radiation that has become now the touchstone of all the observational cosmology.
Okay.
Summary.
That's a great summary of the major players here. And it's not like we want to cast aside Einstein or Hubble, because they are major players in the history of cosmology. But we do want to, you want to, bring back and highlight the fathers, the Lemaitre and Gamow and Friedman. We want to remember them and celebrate their achievements. And I think your book does that, of course, in a lot more detail than we're talking about today. But that's a great summary. Now, tell us about Lemaitre's revolutionary concept of a singularity, a quantum of pure energy that he called the primeval atom. Did he hypothesize this without any data to support him?
Yeah, it's a very interesting question. Well, in fact, the concept of the cosmological singularity was first proposed by the Russian Alexander Friedman in 1922 in the context of models of dynamic universe as a natural solution of Einstein's physics equation. And in his semi-popular book, The Universe as Space and Time, from which I give some excerpts in the book, Friedman even spoke of creation of the world out of nothing. But for Friedman, this was merely a mathematical singularity, namely a point at which all quantities become infinite. So it was, in fact, in 1931 that Lemaitre, independently of Friedman, because he had not read at the time the German, the article of Friedman written in German, because Lemaitre didn't know the German. Okay. Independently of Friedman, Lemaitre proposed the hypothesis of the beginning of the universe in the form not of a point-like singularity, but in the form of a much more interesting, of a quantum of energy, which he called the primeval atom. So as I said, it was no longer a mathematical point, because Lemaitre knew, of course, that it was a physical absurdity that the universe could emerge just from a point. Okay? So for Lemaitre, it was the primeval atom. Primeval atom was a sort of gigantic atom, the size of the solar system. So it was not point-like, the size of the solar system, for instance, which was unstable, and which by quantum disintegration would generate space and time and initiate the observed expansion of the universe. While at the time, to answer precisely your question, at the time there was experimental evidence to the expansion of space that Lemaitre had previously proposed in 1927 through galaxy redshift, there was none to support the idea of the beginning of the universe as a primeval atom in 1931. So Lemaitre, in fact, had simply extrapolated the mathematical solution of Einstein's equation into the past and shown that such a beginning was inevitable in the framework of general relativity. But as you know, it was not until 1965 and the discovery of fossil radiation that we had strong experimental support for the primeval atom, which has in the meantime been ridiculed in some way by most cosmologists as Big Bang cosmology.
Yeah. Well, that's very interesting that Lemaitre was coming up with these ideas. You write that he demonstrates exceptional intuition to come up with these ideas before the data was coming through. So that's quite extraordinary. In a comment published in Nature, the journal Nature, in the early 30s, Lemaitre said this about space and time. If the world has begun with a single quantum, the notions of space and time would altogether fail to have any sense at the beginning and would only begin to get some sensible meaning when the original quantum would have been divided in a sufficient number of quanta. If this suggestion is correct, the beginning of the world happened a little before the beginning of space and time. I thought that was very interesting to think about. How do the concepts of space and time fit into Lemaitre's model?
Yes, fascinating quotation from Lemaitre article in 1931. In a way, Lemaitre is anticipating a fascinating concept that has only appeared in the field of physics in the last 20 years or so, that of emergence. Emergence. Well, in other words, the fact that some notions sought to underlie all physics, such as space, time, gravity, could in fact emerge from a more fundamental substratum that preceded them, such as, for example, the energy of the quantum vacuum, or according to some theory of quantum gravity that I described in a more recent book, which are still under construction, emerge from a kind of virtual network of quantum bits. And in fact, in this discussion in the beginning of the 1930s with the great British astrophysicist Arthur Eddington, Lemaitre raised the fundamental question of the entropy of the universe. Entropy is a thermodynamic quantity related to the bits of information that can be extracted from a given system. And Lemaitre Lemaitre idea is that the single quantum is supposed, he assumes to be at the beginning of the universe, the beginning of everything, thus preceding space, time, and gravity, contains the seeds of all the information we can extract from the universe.
Okay. Yeah, it's very interesting how he proposes that, the beginning and even the creation, and kind of keeping those separate. Well, in 1934, Lemaitre predicted cosmic background radiation in a paper. How long would it be before his ideas would be widely accepted over the steady state universe idea?
Yes, well, in fact, to be more precise, if Lemaitre rightly assumed that the primeval atom must have left behind some cooled remnants that could be observed today, for him, these were cosmic rays, namely, in fact, elementary particles generated by the disintegration of the primeval atom, for him, and moving at speeds close to that of light, which had just been discovered in Lemaitre's time, and not, as we know today, in the form of the fossil electromagnetic radiation, namely photon and not elementary particles, electromagnetic radiation in the microwave domain. So in fact, as I develop in the book, this prediction of a cosmic microwave background was only made in the 1940s by Alfer and Hermann, two collaborators of George Gamow, and it was not confirmed experimentally until 1965. And this is precisely one of the reasons why Lemaitre theory took so long to be accepted during his lifetime, just in the absence of experimental evidence and for other reasons.
Okay. Yeah. I think you write somewhere that it was about a half century before Lemaitre's ideas were really accepted by the community, the scientific community, that is. Well, George Lemaitre was a man of religion, a Catholic priest, in fact. What was his position on the relationship between science and religion? I know you delved into the primary sources. You read his articles and his papers. Did he believe that the origin of the universe was a divine creation?
Yes, this is a very, very interesting question. But indeed, Lemaitre was also, as you said, a Catholic priest, but well, he was exempted, in fact, by the ecclesiastic authorities from giving mass or confessing, for instance. Okay, but precisely this fact that he was a priest played a large part in the reticence shown by his scientific colleagues towards his theory of the primeval atom, because many, including Einstein himself, Kingsley believed that Lemaitre was trying to achieve what we call concordism, namely to reconcile science and religion by presenting the Big Bang theory as a modern-day account of Genesis. However, this was not the case, in fact, when we read really Lemaitre, and Lemaitre expressed himself on many occasions on the subject. He wrote, for instance, if I remember well, that the physical birth of the universe, described by general relativity, should not be confused with a divine creation. In fact, his conception was that of a hidden God who did not intervene in the evolution of the world. Well, of course, we have no time to develop. The subject is much more subtle, and I developed it a little bit more in my book, but I can't do this in detail in this podcast. But it's very deep and interesting questions.
Yeah. You can't just take a few minutes. You do have to unpack that, but you do it in your book. You do quote several things where Lemaitre is addressing this. Yeah. Let me just follow up a little bit on that idea. As your book details, a lot of scientists who were resistant to the Big Bang saw it as suspiciously theism friendly. They even suspected Lemaitre, a Catholic priest, as we've said, of religious bias, which left them perhaps slow to giving his theory a fair hearing. As you say, Lemaitre himself was very cautious about not going beyond the evidence or attempting to defend the Bible with science. From what I recall in his readings, he acknowledged that the Bible was not a science book, and so I remember him saying that. I think we can all admire that he takes care not to overstate the evidence. But at the same time, as I was reading Lemaitre's take on the relationship between faith and science, I thought, this sounds a bit like a man who is under tremendous pressure from a highly secular scientific establishment to, if anything, exaggerate the disconnect between the Judeo-Christian worldview and his Big Bang theory. In other words, he was taking pains to keep them separate. And that's admirable. But after all, Lemaitre would have been familiar with passages in Scripture like Psalm 19, the heavens declare the glory of God, or the Apostle Paul in Romans 1, ever since the creation of the world, his invisible nature, invisible, you say hidden God, namely his eternal power and deity, has been clearly perceived in the things that have been made. So he would have been familiar with all these passages. Here's my question, and perhaps my final one, and we'll join again later to follow this up in a second episode. If all the evidence in physics and astronomy has ended up supporting, or had ended up supporting, a static, eternal, uncreated universe, surely that result could have been viewed less friendly to the biblical idea of divine creation ex nihilo at a definite time in the past. If so, can it be reasonable for some to view the triumph of Lemaitre's Big Bang theory as decidedly friendly to the doctrine of creation ex nihilo? Is it a friendly idea?
Yes. Well, Lemaitre was, of course, perfectly familiar with all the text of the scriptures relating to the creation of the world. In an interview given in 1933 for the New York Times, which is reproduced in the book, he clearly stated, in fact, his conception of the relationship between science and religion. He said, for instance, that there is no conflict between them because both are seeking the truth, but in different ways that have not to be necessarily mixed. For instance, for the Christian believers, he said that once we realize that the Bible does not purport to be a textbook of science, so the old controversy between religion and science vanishes. And for the atheist, he said that there is no reason to abandon the Bible just because we know now that it took 10 billion years to create what we think what we think is the universe, and not just 7 days, of course. So for him, Genesis is simply trying to teach us that one day in 7, metaphorically, of course, okay, one day in 7 should be devoted to rest, worship, and reverence, all necessary to salvation. Okay. In fact, I would say that Lemaitre was a man of faith before he was a man of religion. I think, and this is my more personal point of view, it's important to distinguish between religion and faith. Personally, and I hope I'm not shocking any of our listeners, I don't believe in any religion. For me, there are hundreds of different religions, in addition to the 3 monotheistic ones. And for me, they are all human constructs, necessary for mental evolution and probably the acceptance of our death. But for me, faith in something else. And independently of belief in a given religion, we can carry in our heart the idea of transcendence. In other words, of something that goes beyond matter, space, and time. So for me, that's what faith is all about. And thus, faith is perfectly compatible to be an atheist, for example, and still have this feeling of transcendence. Of course, I'm not saying at all that Lemaitre was an atheist, not at all, but he had the feeling that a supreme form of transcendence, namely God, was inside of us and not external.
Okay, yeah, that's beautifully put. Yeah. And it is interesting, and it is part of the history of science to look at why people came up with the ideas they came up with. You know, what motivated them? You know, we look back to the greats of modern science, Isaac Newton, Robert Boyle, Johannes Kepler. They were motivated by their faith in God, and they did not see, you know, a conflict between science and their faith in God. And they did wonderful science through that, something we sometimes forget. So it's great to look at why people come up with the ideas they come up with. Again, part of the history of ideas, the history of thought, and the history of science. And I really appreciate your perspective on George Lemaitre's state of mind as he developed this revolutionary idea. Well, Dr. Luminet, that's all the time we have for today. But in a second episode, we'll come back and discuss the true heroes of the Big Bang Revolution some more, and how the Big Bang Theory has fared in light of the latest cosmological evidence. So thank you for joining us today.
All right, it was a pleasure, and I will be really pleased to discuss about the second episode of this fantastic history, because Lemaitre is not the only father of the Big Bang. Even for me, it's a main father, but of course, the contribution of Friedman, Gamow, and many others are absolutely essential to understand really the state of present-day cosmology.
Yeah, so, absolutely. And we will unpack some more of that shortly here. Well, to learn more about and get your own copy, listeners and viewers, of the Big Bang Revolutionaries, you can visit discovery.press. That's our new website where you can get access to ordering Dr. Luminet's book. It's discovery.press. For ID the Future, I'm Andrew McDiarmid. Thank you for watching and listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.